Hello and welcome. This is lesson 10.1 and 10.5 combined for Math 128. So we're going to be evaluating some functions. The first one that I have here says evaluate s of t equals 2t squared minus 3t plus 1 when t is -2. The -2 is what you're going to plug in everywhere there's a t and solve. So 2 times -2 squared minus 3 times -2 plus 1. Order of operations, pay attention to the order as you are doing it. Don't just type it all in your calculator. Some calculators can handle it, others cannot. So I'm going to start with this power. -2 squared is 4. -2 squared means -2 times -2. I have -2 times negative, or -3 times -2, so that's positive 6. And then we're just going to move left to right. 2 times 4 is 8, plus 6 plus 1. 8 plus 6 is 14. 14 plus 1 is 15. Again, you want your final answer to have followed order of operations. For example 2, I have a fraction. F of x equals 4x over x squared plus 2 when x equals 2. With functions, we are using this notation f of x. We can have g of x, h of x, etc. It's just a name for the equation, and they're called functions. So 4 times 2 over 2 squared plus 2. So 4 times 2 is 8. 2 squared is 4. And then we're going to go ahead and simplify again. 8 stays on top. 4 plus 2 gives you 6. And we never want to leave a fraction in improper form. So we'll go ahead and change this to 1 and 2 6. And then hopefully you notice that 2 and 6 can both be divided by 2. So we'll simplify a little further to 1 and 1/3. Evaluating functions is the first part of this lesson. Then we're going to move on to looking at circles. And we're going to talk about circumference and area. And we talk about it as it relates to equations and how that is going to go with this lesson about evaluating functions and exponential functions. So I'm going to draw a circle, and I'll draw a second one. And I'm going to draw this line that goes through the center that goes all the way across. Hopefully you remember that's called a diameter. And in my circle that I draw next, I'm going to go ahead and do the center and a line that goes halfway across. And hopefully you'll remember that's the radius. And then on the outside of the circle, I'm going to write the word circumference. Oops. As many times as I can all the way around. Circumference is a distance. It is the distance around the outside of the circle. We have a formula for circumference. It is pi times the diameter. Now, many times you've been told pi is just 3.14, but it actually has several more digits. And if you're using your calculator to solve these problems, you should be able to find a button that says pi on it. So take a look at whatever calculator you have, and you'll want to find that button, because when you're doing the homework, if you just use 3.14, it will not round correctly and it will count it wrong since it's all self-graded. So put a little note here, use the pi button on your calculator. Please, please, please make sure you make that note. Anything that has pi in it for our purposes, we want to be able to use the pi button. All right, and then the diameter is what we need. So we need the whole length across. So this says, given the circumference of a circle is found by pi times diameter, find the circumference of a circle whose radius is 4 inches to the nearest tenth of an inch. So if the radius is equal to 4, the diameter is twice that, or 2 times 4, or 8. So for our calculator, again, we're going to use that pi button, and then we're going to multiply by 8. So I'll grab my calculator. Hopefully you have yours there as well, and you can do this problem with us. So 25.13274,123. And that says round to the nearest tenth of an inch. So that's 1 decimal place. So we look to the number after it. If it's 5 or higher, we round up. Otherwise, we leave it. So 25.1. And our units will be the same that our radius and diameter are measured in. So inches. So if we were to cut a piece of string and put it all the way around our circle, we would need 25.1 inches of string. Again, circumference is the distance around the outside of the circle. As we keep going, we're going to change gears and look at area. So given that the area of a circle is found by pi r squared, find the area of a circle whose radius is 15 centimeters to the nearest tenth of a centimeter. So we are given the radius is 15 centimeters. We have our formula here, pi times r squared. And again, we're going to use the pi button on our calculator. And then our radius that we are given is 15. So grab that calculator and do this with me. Pi times 15 squared. And remember, 15 squared means 15 times 15. So 706,858,3471. And again, we want 1 decimal place. So we look to the number after. If it's 5 or higher, we round up. So 706.9 centimeters squared. Area is always going to be units squared. Area represents the amount of space inside the circle. And we're going to be doing area of lots of different shapes over the course of our time together. So area will always mean the space inside. All right. For the next one, example 5, I'm going to go ahead and mark out B from my previous notes because we're only going to do one of these together. The time t in seconds it takes for a pendulum to make one swing depends on the length of the pendulum and is given by t of L, that's the name of the function, equals 2 pi times the square root of L over 32. Where L is the length of the pendulum in feet. Find the time it takes the pendulum to make one swing if the length of the pendulum is 5 feet. Round to the nearest hundredth of a second. So 5 feet is our length, and we're rounding to the nearest hundredth, which is 2 decimal places. So we're going to go ahead and do this problem. So length equals 5 feet. That's our given. And then I'm going to go ahead and write down our function that we are given in the problem. And then we'll go ahead and plug things in. Again, anytime we have pi, we want to use that button on our calculator. So I'm just going to put it in a square to help you remember. 2 times the pi button times the square root. And inside the square root is 5 divided by 32. So I'm going to grab my calculator. 2 times pi times the square root of 5 divided by 32. And on my calculator, I have to close a parenthesis for the square root. So I'm going to go ahead and put a little parenthesis around the 5 over 32. If yours doesn't do that automatically, you might want to add that piece. And then that's 2.4836470066. And again, this one says round to the nearest hundredth. So 2 decimal places. Looking to the number after, it's not 5 or higher. So we're going to leave it 2.48. And we are finding the time it takes. So this is in seconds. Again, pay attention to the measurements. This one was all in feet, and they asked us to take and put that 5 feet in. All right, we're going to switch back to a little function work. I started out with that. We're going to have a few more of those. Again, order of operations matters. The function we're going to start with is f of x equals 3 to the x power. We're going to find f of 2, f of 0, and f of negative 2. So we're going to start out by taking f of 2 equals 3 to the second power. We're replacing the x with the value in the parentheses, the number that's inside that parenthesis. On the first page, it said, evaluate it when x equals 2, and we did the same thing. So our notation has changed, our process has not. 3 squared is 9, 3 times 3. F of 0 then means to take 3 to the 0 power. Any number to the 0 power is equal to 1 by definition. You also can do these on your calculator and it should work out. And then f to the negative 2 power, or f of negative 2 is 3 to the negative 2 power. And that's really the same as 1 over 3 squared, or 1 over 9. Again, on your calculator, it should be able to handle each of those. For the second set, g of x, again, just another function with a different name. G of x is equal to 3x minus 2. We're going to find g of negative 4, g of negative 1, and g of 0. Same as before, we're just going to be plugging that value in everywhere there's an x. So g of negative 4 equals 3 times negative 4 minus 2. Order of operations, do the multiplication first. 3 times negative 4 is negative 12. And negative 12 minus 2 is negative 14. G of negative 1 equals 3 times negative 1 minus 2. Do the multiplication first. Negative 3 minus 2, or negative 5 when you simplify. G of 0 then would be 3 times 0 minus 2. 3 times 0 is 0 minus 2, or negative 2 when you simplify. Again, as you're looking at these, pay attention to order of operations. You need to review order of operations. You should be able to find some extra help for that by Googling it. Please excuse my dear Aunt Sally, might remind you of what order of operations are. And I'll go ahead and write that down here. Just so if you are having trouble, you know what you need to ask for help with. Please excuse my dear Aunt Sally. The P stands for parentheses, E for exponents, M and D are multiplication and division, A and S for addition and subtraction. Again, hopefully you do remember doing that in the past. All right, example 7 then is an application of exponential functions. It says a radioactive tracer is used in medical scans to monitor blood flow. The tracer has a half-life of 4 hours. A patient is administered 50 milligrams of the tracer. How much of the tracer will remain in the patient's body after 12 hours? So as I was reading, I went ahead and marked what I felt was the most important. The half-life is 4 hours. Our patient got 50 milligrams, and we're trying to find out how much is left after 12 hours. Those of you going into nursing and medical fields, this is one of the things you'll be doing. If anyone's ever had to get any type of drug test or find out if the drug is in their system, this is what the drug test is doing, checking to see how much is left. Or if you've ever wondered why your doctor tells you to make sure you take the medicine at the same time each day, again, this is another reason why. We want to maintain a certain level of that prescription in your bloodstream. So our general form here is A of T equals A sub O. That O stands for original amount times 1/2, because it's called a half-life, half of it's left after 4 hours. And then our power right here that you may or may not be able to see really easy is little t over capital T. Our little t stands for time, and our big T is the half-life of the substance. And then we're just going to plug in numbers and simplify. So our original amount that we started with is 50 milligrams. We know the half-life to be 4 hours, and we know that we are trying to find how much of it is remaining after the time of 12 hours. So our power is going to be 12 divided by 4. Again, our half-life is capital T. The time we're interested in is little t. So we're just going to go ahead and simplify a little bit. Our power, 12 over 4, becomes 3. And then we can use our calculator to help us from here. So grab it, type 50 times parenthesis 1 divided by 2 parenthesis, and then use that caret key, which we use for exponents. On my calculator, it looks like a little rooftop. Again, you may have a different calculator, but that is my power key. And I'm going to take it to the third power. So I end up with 6.25 milligrams of the tracer after 12 hours. So they're still able to detect it 12 hours later. Again, half-life in another 4 hours, we will have half of what we have today. And then it will keep simplifying, reducing, and have less and less over time as we go. Thank you for joining me tonight, and I look forward to our next lesson. Thanks.